Greetings and welcome, friends. Mr. Waddy and my G amigos here. We were talking about the triangles the other day, which I don't know if you guys knew this, but tri means like three. Yeah. And so we were classifying based on the sides and the angles. And so based on these sides, it looks like there's two that are congruent. I've got a hand raised. What are your thoughts? That's the isosceles. And based on the angles, there's one right angle, so I agree that it's right. Yes, question? Comment? An equiangular triangle will happen to have all acute angles. The internet friends, the student question was, what's the difference between acute and equiangular? So if I have an equiangular, and I know that all of those add up to 180, they all end up being 60s. And so all of those do end up being acute. But an acute triangle would also be one that had a 61-degree angle and a 59-degree angle, which would no longer be equiangular, but is still in the family. Maybe it just wasn't the most specific name you could have given for it. So let's see. On this one, it looks like all three side lengths are different. Thoughts? That's based on the angle. Yep, there's one angle that's grande. So we'll call this an obtuse triangle. And my other friend in the back, man, this is awesome, guys. It's scalene. Scalene is when all three sides are different lengths. My friend with the hat, do you got the packet 5-1? Want me to get it for you? All right. Okay, here we go. Oh, man, this problem. Guys, help me speed run this, would you? All right. Distance formula is x2 minus x1 all squared plus y2 minus y1 all squared. You know what, guys? Waddy on the spot. Desmos calculator. All right, I'm going to open up a Desmos here. And let's plot these points real quick. 1, 9, 4, 8, and 2, 5. Question 9, was it not on your packet? All right. Whew. Purple, 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 make it. Here we start wearing purple, wearing purple. All right. So here we go. Looks like I've got a triangle, something like. Let's full screen. Watch this trick I learned. Windows button double plus sign will actually make it invert colors. Windows. Well, it won't work for Chromebooks, but I'm sure they've got an invert option hotkey. And then Windows, yeah, high contrast mode as well. All right, so here's my setup. Let's label our points. A was over 1 up 9, so there's my A. B was over 4 up 8, B, and the other one's Charlie by default. So I've got to figure out these distance using the distance formula. So let's find AB, and I'm going to speed run this. You guys are, look at that, my equal sign in the square root. Bah, Mr. Waddy. 4 minus 1 squared plus 8 minus 9 squared. So notice I'm doing x2 minus x1 all squared plus y2 minus y1 all squared, and then square rooting it. In the back, my friends, track with me. 4 minus 1 is 3. 8 minus 9 is -1. Keep that in parentheses because when I square it, I'm going to have the square root of 9 plus +1 is the square root of 10. So from the A to B is square root 10. Let's get a decimal approximation for that, shall we? It should be about like 3 point something, right? 3.16 we'll call it. So let's see. Let's find BC rapido. So from B to C, 2 minus 4. 2. And 5 minus 8. Guys, track with me, please. Plus side conversations happening. I know you guys are distance formula experts based on your chapter 1 test, but I'm just going to speed run this. 4, -2 all squared is 4, -3 all squared is 9, so that's the square root of 13. Rad 13 is approximately 3.61. Square root. Yeah. Also, I would say Raphael of the Ninja Turtles is also rad. Both of those answers are acceptable. Michelangelo is a party dude. I don't know if he's rad. But anyways, so guys, then I've got to figure out AC still, all right? So I'm going to do 2 minus 1 and 5 minus 9 in that distance formula. Oh man, that radical is right there. All right, 2 minus 1 all squared plus 5 minus 9. At least our internet friends could fast forward through this, right? Too bad the rest of us. Let's see, here we go. I get 1 squared is 1, 4 squared is 16. 16, yep. No worries. Square root of 17. Oh, Mr. Waddy's got a... Waddy? How can I help? Very good, will do. Nah, this is raw, man. You got your crackers, it'll be good. So, all right, here we go. So, notice all of this work to realize that these distances are differences. Whoa. So, that just tells me this is scalene. Guys, what do you think about whether this triangle's right or not? So are you thinking it's acute or obtuse? I think it's acute. This angle right here is the one that I would question. The slope of this line is M1 is negative 1 over 3. The slope of this line is up 3 over 2. So those aren't opposite reciprocals. And it looks like if it was 90, it would have had to be here. And so it would have been less than 90, so it's acute. I'm comfortable with that claim. All right, so that problem takes a little bit of time. I won't, yeah. It's just a lot of distance formula. I hope you guys liked all my arithmetic right there. So let's see, J-Dog, let's take a look at this. The trisum theorem. What was the triangle sum theorem? Yeah, they add up to hundo ete. So according to trisum, I could say measure angle 1 plus 31 plus 78 equals hundo 80. Yes, sir, J-Dog. Claim is 71. Let's see what happens. 31 and 78, is that 109? Subtract 109 from both sides. And our algebra skills. Looks like 71 degrees. I agrees with you. Oh, man. If you like these puns, comment below. Oh. All right. Okay. Exterior angles theorem. You guys got these in your spell books. Good old theorem packets. You got exterior angles theorem says that the two remote interior angles add up to be the exterior angle. So, according to the exterior angle, I could say theorem. Yeah. 2x minus 2. Let's see. Claim is it's 92. 45. Ooh, I got to pay attention. Oh, look at that. I would have probably just solved this for x and thought I was done, but I would not be. So I would have had 2x minus 1x is just x. Add 2 to both sides. Looks like I'm getting 47 for x. So notice this angle. I'll tell you what, we'll leave it in green. I'll call this angle 3. Why not? I don't know. Measure angle 3. I'm running out of room. Is equal to 2 times x minus 2. And so I could then substitute 47 in for x. Right? Right. And 2 times 47, that feels like 94 to me. And so I'm getting 92 degrees. Measure. Oh, yeah, I had some space underneath. Measure angle 3 equals 92 degrees. Agreed? Disagree? All right, I've got some agrees. So this angle is obtuse. Oh, question. If this angle is obtuse, is the triangle acute, right? Right, if this angle is obtuse, then this angle must have been less than 90 because it adds to 180 by a linear pair. So this would have been an acute triangle. That's a little question. For this one, let's just do the setup for it. I'm not going to spend more time on it, but it's the same idea. What's my setup for this problem? What is the equation? Yeah, the two remote interior angles, right? This one and this one add up to be the exterior angle, right? So notice this angle right here, I would not consider to be remote because it is adjacent to or touching the exterior angle. Let's see, students, what was the answer you guys were shouting out? Did x equal 12? And then the measure of the angle is 68 degrees. All right, that's the claim, internet friends. You check it. All right. Else. Okay, here we go. Let me draw a picture here for us. The measure of one acute angle is 5 times the measure of the other acute angle. Oh, and also they gave me the fact that this is a right triangle. So here's a right triangle. Here's a tiny acute angle. And the other acute angle is a lot bigger. 5 times as big. So I could call this like 5x. So drawing that picture, even if it wasn't to scale, because this doesn't look like it could fit in there 5 times, that's fine. Don't matter none. Let's solve this. So here I could use trisum and say 5x plus x plus 90 is 180. Or I could use the corollary to the trisum theorem. What would that claim? You guys remember the corollary to the trisum? Yeah, I would just take the two acute angles and say that they add to 90. So the corollary of the trisum, it's just like, oh, subtract the 90-degree angle from 180. Kind of really happening. So I would have 6x equals 90, div 6, and I feel like I should know what that equals. $15? All right, my brain was low on that one. That's all right. Find the measure of each acute angle. Oh, okay. So that means this one is 15 degrees, right? And 5 times 15. Thank you. Yeah, 75 degrees. Not bad. So the two acute angles in a right triangle are complementary. They add up to 90. And, internet friends, check this out. We got a proof. Hey, you want to use that exterior angles theorem? How about you prove it? Here we go. So I've got a little fill-in-the-blank proof going here for us at the moment. That may be the case. I mean, there are multiple ways of proving things. The Pythagorean theorem is the world's most proven theorem with over 300 unique proofs. So it is possible, although what's weird is I literally stole this from Big Ideas. I would have thought their online proof and their offline proof would have been the same. That's fine. All right. Oh, which ones I erased? Yeah, would be different, but maybe their logic was the same though. We'll see. So given there's a triangle and a cool exterior angle, let's prove that the two remote interior angles add up to be that exterior angle. So they gave me some given information. We know how to do that. Then they said this: measure of A plus measure of B plus measure of BCA equals 180 degrees. How do you think they got that? All similar, but in this case it's just trisum, which we did prove trisum using angle addition postulate yesterday. So yeah, all three of those interior angles add up to 180, so that's trisum. All right. Then they said BCA and BCD form a linear pair. What are they talking about? So, form a linear pair. So this angle here and this angle there, Those look linear to me, right? Linear pair. Yeah. That's definition of LP. Now, ladies and gentlemen, just because I give you a fill-in-the-blank proof and this entire row, please, this entire row was already completed for us, doesn't mean that you should just ignore what it was claiming, right? To familiarize yourself with the logic of a proof, still read those rows. Make sure you understand what's happening, right? J-Dog, just because you could write down the things that are going in the blanks doesn't mean you know how to do this proof. So I want to make sure you're still engaging your brain with those pieces. So yeah, that's a linear pair by definition of a linear pair. And then they said BCA plus BCD's measure, right, the measures of, equals 180. Claim, why is that true? LPP, yeah, you know me, linear pairs are supplementary. So linear pair postulate, you guys got that in your spell books as well. All right, where on earth is this coming from, folks? Let's see, 5 says measure A plus measure B plus this. I've seen that up here. And then it's got this, BCA, BCD. I've seen that down here. I'm assuming they're combining these two somehow. How are they doing that? Subs? Yeah, check this out. This part is equal to 180. This part is equal to 180. I could take this and plug it in for the 180 part, swap those out, you'd never know the difference. So, subs is a legitimate reason. Technically, I also could have claimed transitivity. This equals 180, 180 equals that, therefore they're equal to each other. Okay. The clue is that they're subtracting something. The other argument my student is making right now is that it's the last step is always going to be what I set out to prove. Right? Yeah. So that's another way I could have figured this out. But let's see if we can understand what they were doing. What could they have subtracted from both sides? What was, and I realize it's a little bit weird how they wrote it on 2 rows, but what is on this side of the equation that is also on that side of the equation I could take away? Yeah, BCA. All right, so I would have measure angle A plus measure angle B equals just plain old measure angle BCD. And that proves the exterior angles theorem. And now that it's proven, I can use that theorem for the rest of forever with confidence that I know what I'm doing. All right, well, thanks for watching, internet friends. Me and my amigos, we're going to be talking about all sorts of geometry today. It's going to be so great. Adios.